tips and tricks one, this one. Reasons why I suggest you invest in a bench power supply. Okay, so we know that you can very easily buy little power supplies here, there and everywhere that will do the job. They'll produce power. That's a 5 volt 5 amp, that's a 12 volt 5 amp, and that's another little 5 volter. And yes, they will all produce enough power. They'll be able to power your circuits, as long as you never make a mistake, because each one of these is producing its power all the time. In other words, it's literally it's like an engine running at full revs. It's great until you drop the clutch on it and everything ends up quite disastrous. Plus, the other big worry I have, particularly if we're looking at youngsters, is you've got your live, your neutral and your earth on your high voltage sat right there. And although they put a nice little plastic thing over there, all it takes is a slightly frayed wire, slight problem, and you've access to the high voltage, which, you know, is just it's far too much of a risk. I don't even like using these things in the big industrial stuff we do. I actually find myself nervous around them, because if you aren't watching where you're putting your hands all the time, it can be too late. So, your choice, guys. If you want to use these, I mean, there's also the bigger ones. This is one of the really bigger ones. That's a nice 30 amp power supply, but again, high voltage is sat out on display. The reason I suggest that it's worthwhile getting a bench power supply, number of reasons. The biggest one is how much it will help you, not when you get it right, but when you get it wrong. And just a quick, this is probably the cheapest one I've ever bought. I think it was about £30 on eBay, brand new. Does the job, but you've got to know a little bit how to set it up insofar as it doesn't obvious. And the first thing you have to check is that when you power it on, you don't connect it to anything, because you never know where that voltage is coming on, because you never know just where that switch has been bumped in between using it. But for a cheap power supply, as long as you follow the rules, and first thing you do is put it onto a voltage, which will set that at 5 volts. And then the other, and this is the big thing, if we then short those out, which sounds counterintuitive, because on one of these, you potentially blow it up. Whereas on this, they are designed to stand being shorted out. There's a button there that goes between volts and amps. When we press that, and that shows me that the CC tells me it's shorting out, but it tells me that I'm only shorting out 100 milliamps. Now you can turn the current right up, and it is quite happy. It'll stand shorting 2.1 amps out, so that if you make a mistake, if you turn that right up, you can have 2.1 amps going through your mistake. And if that's a nice processor that you spent a lot of money on, then you will get the lovely little plume of smoke. The nice thing is that once you've set that, and let's go back to the voltage is 0 now, because of course they're shorted out. I'm saying of course, it might not be obvious, so we've now separated those two. We're back to 5.1 volts. What I've got there are two LEDs, one the right way round, one the wrong way round. And on this power supply, if I connect red to one side, black to the other, one of them lights and the other one doesn't. But it doesn't die either, because there's only 100 milliamps pushing back. If you remember, we went over to the side, it's actually showing 0, but there's only 100, so it's actually not even shorting out, partly because of the resistor. But it's getting close. You can see it's hovering. Because that's only got 100 milliamps going through it, then that resistor, although it's the wrong way around, is staying unlit. So if I now take that and swap them over, he says, but dropping them, get hold of it, and I'll swap those over. You have to take my word for it, but the other one lights, because the one that was being shorted out although it wasn't shorted out as such. But although the one that was getting incorrect voltage going the wrong way through it, the 100 milliamps milliamps wasn't enough to actually damage the component. And your processors are the same; they will stand a certain amount of abuse. So if you've just spent a lot of money on a really nice big processor, and you do the fatal mistake that we all will make, and you will make it, everybody does it, of getting plus for minus, minus for plus, and doing it wrong way around, you don't burn yourself a processor. You literally, it just sits there. Now then, when I'll prove the point, because we've got one there running. If I now turn up that current, eventually that little LED will pop. He says maybe this little power supply hasn't got enough power to do it. That'll be interesting. Whether the actual now you saw it go into so there was that little power going through the circuit because I could turn it down, so beautifully controlled. It actually thought it was being shorted out because it was saying that I'm sending it out and it's not getting through. Which is as I said, the nice thing is that what you've got is a situation where that component has probably even survived that, which is probably a testament more to having the resistor on than it has. So what we'll do is we'll actually bypass the resistor just to prove the point. I'll take it down, the voltage down a touch, so that we're being fair, we're not just blowing it up because it's too much voltage. So we've now got, and you can see now we are getting the, so one of them is shorted out, so the other one is lit. But the one that's shorted out, and this is where I will be very careful how I swap them over so you can see, I'm going to take the black off, take the red off, put the red on the black and the black on the red, and that's LED, despite being shorted out, has survived. But just in the same breath, if I now turn the current up, which is like one of your cheap power supplies, then, well, I'm going to be impressed with these LEDs. They're probably doing a lot better than a processor would. It'll be interesting to see whether it's just a case of it says it's. I'll swap them over just for the pure interest. No, it's survived. I've got to say, the components are getting more sturdy, but processors aren't. Perhaps it's not the best example. Perhaps I should blow a processor up just to prove the point. One other thing that's worth mentioning, and this is the nicest thing about it all, is if you've got a bench power supply, because it uses what are called banana connectors, and they're called that because of the shape of the metal on the end, you can also have a second wire going through to your meter, so that without taking anything over it, you can check things in your circuit without having to find a second thing. So if I now leave that on there, that will now show the voltage, and if I bring the voltage up, you see the voltage go up. Now that LED is now struggling because of the voltage, which is where one of the reasons that we put, if I left that there for long, that if I actually look at it, if I left that there for long, that LED would be damaged with the heat. One of the reasons that we put the diode in, the 5 volts can very easily damage an LED. The 330 resistor stops that happening because Ohm's law will not go into that. But as you can see there, I can analyse the voltage very easily with one hand, which is another reason why I suggest these power supplies. If you can afford a better one, this is nice. This is one of my better ones. On my main system, I'll show you a picture of that. On my main system, you'll see that I've got a whole stack of different devices, and one of the bottom one is a multi voltage, which allows you to do a lot more than I've ever needed to, and a frequency converter. And then at the top, I actually have a big multimeter that's all chained together, so that I only need one hand when I want to use the multimeter. So coming back to this, that one, M1 gives me 3.5 volts, M2 gives me 5 volts, M3 gives me 12, M4 gives me 24 volts, and there is a fifth one, which I can never remember how you get to it. But the nice thing is on this, which is where again the more expensive power bench power supplies do, it doesn't actually put the power on until I press the on and off button. So you don't, as you're selecting your voltage, you can actually leave it connected into your circuit because the actual power isn't going through. And each one of these memories you can set to any voltage you like. I just have it set to my classics that I use all the time. So my recommendation is, partly because of the danger, that one doesn't even have a piece of plastic on it. They're trying to shroud it. One bare wire is all you need on your high voltage, and one of the big things we always used to say over here is it's half a day out with the undertaker, or as you guys over in America call them, the mortician. And so they're nice, they're cheap, but for the amount of money you're going to pay for that, you're not going to spend a lot more buying something that will protect your components. And that's about it for today.